Okay guys, welcome back. Sheet 6, tangent plane, solids in contact. So, part 1. You've got a sphere, you've got a point on the sphere, and you're told to draw the traces of a plane that is tangential to the sphere at a given point. Now look, the approach to solving this is we're going to find where that point is in plan by, you can imagine it as chopping off the top of the cone. So if I took a horizontal section and chopped off, the sphere, if I chopped off all the top of that sphere there, that's going to give me a circle in plan. Now the radius of that circle, I can take it from here if I want. So the radius of that circle in plan is going to be this. So I don't need to draw all the circle, just a little bit of it will do. And P is on that circle. So when I bring it down, that there is point P. So that's the first thing you need to do, is just find point P in plane in the top view. So the next step then is we want to put what's called an enveloping cone. So that's a cone that fits exactly in contact with the sphere here at the height of P. So again, that's pretty easy, I guess, because that section that I took here is the circle of contact where the cone is going to be hitting this sphere. So what I want to do is I want to join to the center here. It's like drawing a tangent to a circle. I want to join to the center and I want to go off at 90 degrees to that. So you just have to take your time and be a bit accurate. So this here now is the size of the cone. Now I don't need to draw all of the cone really. Okay, because really all I wanted is the top of the cone and the radius of the base. So I could draw the other side if I wanted, but I'm not going to bother. So that's the front view of that cone, half that cone. So here's the radius for the base of this cone. Again, I don't need to draw all of it. I will put in the most of it here. Okay. So this circle here, that circle there represents the base of this cone. It's touching the sphere at the height we chopped it off at here all the way around. So that is not a, that's not a point, that's not a line, that's actually the edge view of a circle of contact all the ways along here. And what I want to do next is I'm going to draw a red line here now. This is my line of contact now. That red line here is the line of contact where the oblique plane is lying up against the cone, and of course P is on that. Okay, so that's the line of contact. So the horizontal trace is 90 degrees to that line of contact there. So I just get the angle of that line of contact, go off at 90. That's the horizontal trace. And of course the vertical trace in the top view is in the XY line. I can't see it. So that's the horizontal trace. And the vertical trace is in the XY line. But in the front view then, looking in from the front here, I will see the vertical trace. So I'm going to just bring in the apex of the cone. I could also bring in P, but I've been through that before, so going to bring the apex of the cone into the vertical plane. We know the height of that in the front view, so bring it up, bring it across. That there is a point on the vertical trace, and I'll just draw in the vertical trace now, and that's it, we're done. So that's the vertical trace, and of course the horizontal trace in the front view is in the XY line. So that is, I suppose, the key point that a lot of people forget or get stuck on, is that the vertical trace and the horizontal trace in the front view, and you've got a vertical and horizontal trace in the top view. So that's 4 traces, but the horizontal trace is in the XY line in the front view, and the vertical trace is in the XY line in the top view. So really we don't, letter them or whatever, because it would just be confusing. So there's it, that's it done. Just a matter of making the right angle of a cone. Now the next question here then, it said there's 2 spheres on the ground. Draw the traces of a plane that's tangential and makes an angle of 60 to the horizontal plane. Now I just mentioned in question 1 up above that it's all about making the right angle of a cone, and because they told us this is actually quite easy, because the idea here is, if you've got, I guess I don't even need the vertical plane here, but if you've got a sphere and a smaller sphere back behind it here on the ground, and what they're asking for here is basically you have to make a cone of 60 degrees and a smaller cone here of 60 degrees, tangent cones, and basically if we lay any flat surface then up against them, the angle of that plane there is going to be 60 degrees to the ground, because you're lining it up against 2 60-degree cones, and that's the method behind what we're going doing. So we're going to make 2 60-degree cones. So this is easy. So how much of the cone you draw is the thing. I'm going to extend up the center axis of the cone. So here's a 60-degree cone. Again, you don't need to draw all the cones here. So that's a 60-degree cone enveloping the small sphere. There's a 60-degree cone enveloping the big sphere. Like, draw the other side if you want, but there's no benefit to it, because all you want here is the radius for the base of these 2 cones. So here's the radius of the base of the big one. And here's the radius of the cone on the ground for the smaller sphere. Like that, and there's no benefit to drawing all of them. And then your horizontal trace then is a tangent to both of these cone bases. So you just line it up. I'll use a blue pen this time. So that's the horizontal trace, and we just use our normal. Now that is not 60 degrees. I have no idea what angle it is, but it's nothing to do with 60 degrees. You make the 60-degree cones. You make the 2 60-degree cones, and then you go tangent to the base of them, but so it won't be, the trace won't be 60 degrees, just the cones are 60 degrees. And finally now I want to go parallel to that. So I could bring in the apex. I usually go for the taller one because it's just more accurate. So the apex of the bigger cone, bring it in, bring it up, bring the height across. So that there is a point on the vertical trace. And I'll just draw that in blue pen in as well, just to make it stand out a bit. So that's the vertical trace and the horizontal trace. So that's the horizontal trace, and I didn't draw my vertical plane there. It's not going all the ways into sketch, but hopefully you understand what I'm talking about. Okay, now question, oh sorry, I did 1 and 3, sorry, yeah. So question 2 is next. So given the projections of a cylinder, so that's a cylinder and a sphere, get the traces of a plane that's tangential to the sphere, makes a 70-degree angle to the horizontal plane, so we're talking a 70-degree cone here, which is fine, and passes through the given point P. Okay, so we want it going through P and tangent to the sphere. So basically the answer here is a 70 degrees cone, so you're going to need a protractor. Or the other answer, instead of protractors, you can use these adjustable set squares here as well. So I just set that to 70 degrees, and they're handy, alright, yeah, if you do have them, but a protractor I suppose you're more likely to have a protractor. So there's my 70-degree cone. And that's the apex of my 70-degree cone. Now, I suppose there's 2 ways I could do the second bit of it, but I'm going to make a 70-degree cone that's going through P here. Now, I suppose, yeah, I'm going to make a 70-degree cone going through P, and so P is the apex of this cone. So that's half a cone here with a 70-degree angle. That's a half a cone here with a 70-degree angle. Now, as I said, if it helps you understand it better, you could draw the whole thing in. So I'm going to draw the base of those cones now in plan. So I'll just set my compass here to the base of that. So this is the base of my enveloping cone. And this is the base circle of the cone that's going through P. Now be careful now, because that's a cone that we're drawing with P as the apex. Okay, so P was the apex of this second cone, and I suppose similar to the last one we looked at there, the horizontal trace then is a tangent to both of these. So just line it up. That's the horizontal trace, and we will just bring in, I think I might use P. Alright, I could use, doesn't matter, I could use P, or I could use the top of the cone as well, of either one of the cone. So I'll bring in the top of the cone. So bring it into the XY line, project it up, bring the height across, and that there is a point on the vertical trace. And there we have it. Now I might just put a sketch there. I'll just pause this and put a sketch on. Okay, so what we had here was a sphere and a cylinder with a point P here on the top circle surface there of the cylinder, and what we wanted then was two cones. So I might just sketch the cones in there in a different color. So we made a tangent cone at 70 degrees to the sphere, and then we made a tangent cone at 70 degree tangent cone from that point P, and the horizontal trace then was a tangent to both of them. So that's my horizontal trace, and then we just ran in the apex of, I used the corner, so we just ran that in then parallel to find a point. Where's that on the trace? And that there then going through that was the vertical trace, and that's my oblique plane here then going all the way along here. So that's my oblique plane, and I suppose I didn't draw them in, but I could have drawn them in. There's a line of contact there and a line of contact here if I wanted to put them in, where the oblique plane is lying up against those cones. And if I wanted to put them in there just to help you understand it, so that's the line of contact where it's lying up against it, and over here also. So that's where the oblique plane in red is lying against the cones that we made. So this last question here, then we've got an inverted cone and a sphere. Determine the trace of the plane that's tangential to the sphere. Incline it 60 degrees to the horizontal plane and touches the base of the inverted cone. Okay, so that's easy enough, I feel, because if I was to sketch this again here, what's a good angle to look at it at? So if there's our planes of reference, we've got an inverted cone that's kind of out here somewhere. We've got a sphere that's back here somewhere, sitting on the ground. So what we're going to be doing is we're going to make a 60 degree cone enveloping the sphere. We're going to make a 60 degrees cone that's enveloping the inverted cone. So I know that looks a bit funny, but our horizontal trace then is going to be tangent to both of them, and when you bring in the apex of one of them to get a point, that's going to be the vertical trace, horizontal trace. And if you wanted to complete that, it's going to look like this. Then that's our oblique plane lying up against both of them. So that would be the line of contact there, and that would be the line of contact here. So that's the technique. So I'm going to use the 60 degree set square. So here's my 60 degree cone in elevation. Here's my 60 degree cone enveloping the sphere in elevation. So two 60 degree cones. Again, all I want is the base radius for them. So that's the base radius. This is the base radius for the inverted cone. So it's pretty unusual to be doing enveloping cone for an inverted cone, but sure, it is what it is. So I don't need to draw all of them, there's no benefit, because I only need enough to draw my tangent. So this is the horizontal trace. So there's the horizontal trace, and then I'm going to shoot in the apex parallel to the horizontal trace, because that keeps the height the same. When you go parallel to the trace, it keeps the height the same. So bring the height into the vertical plane, bring it up, height across. So in other words, that's the elevation of this line where we brought the height in. That's the elevation of it, and that there is a point on the vertical trace. So vertical trace, horizontal trace, and again, if you wanted to put in those red lines, you weren't asked, but I do think, you know, if you won't really understand it if you don't understand these lines of contact. So they're just 90 degrees to the horizontal trace. So that's my line of contact here. That's my line of contact there. And if you wanted to know the exact point then where it's hitting the inverted base, this wasn't asked for now, but the point of contact where it's hitting the inverted base, I could bring it up from here, and as you can see there, it's pretty close to the edge. It's just inside from it a little bit, so just in there. There's the point of contact if you were asked for it, which you weren't. So that's the last one. So yeah, hope you enjoy or find that beneficial. See you later. Good luck.